All right. So on this one, so I am going to kind of repeat myself just a little bit. Remember that the log base of x is equal to y, and then that relationship is b to the y equals x. And we could solve it, but the main thing is that these are inverses of each other. Okay. So what I can do, first of all, I'm going to clean this up a little bit. Remember that there's a property that when we have log base b of m plus log base b of n, that is equal to the log base b of m times n. Okay. In other words, and so we got to double check this. So what I'm saying is, first thing you got to do before you start applying the properties of logs, check the bases. Are they the same? Yes. So that means that I can take this and multiply it by this. In other words, you'll see, I could say log base 4 of x plus 3 times x. And then that's equal to 1. Okay. So what the property is saying is I could take this and multiply it by this and put it together as one log. So what I'm going to do is I'm going to distribute the x through the parentheses. And so that means that this becomes the log base 4 of x times x is x squared plus 3 times x, which is 3x. And that's equal to 1. Okay. You guys with me so far? Okay. So now the next thing that I need to do is I'm going to make this, whoops, got a little carried away there with the highlighter, but I'm going to make it look like this. So my base then is 4. Well, let's label it. I think that helps too. So my base is 4. And then this is like technically the x, right? So this would be x squared plus 3x is like the x of this scenario. So that's like my x, which is confusing because it's like you have x's that equal x and stuff. But I apologize. There's no way around that. And then this is the y. It's cold now. So now I need to write this as b to the y equals x. So it would be 4, right, to the 1 is equal to x squared plus 3x. 3x. Oh, I did it again. Okay. So 4 to the first power is just 4 equals x squared plus 3x. So now this is a quadratic, so I can factor this by, or I can solve by factoring and setting it equal to 0. So I got to set it to 0. So I'm going to subtract 4 from both sides. And when I do that, I'm writing to the side for a reason. I'm going to get 0 equals x squared plus 3x minus 4. Now remember, we have to factor this and set both of the factors equal to 0. And if I taught you Algebra 1 last year, you kind of remember this. For some of you that didn't have me for Algebra 1, this might look a little new. But basically, I take the first term and the last term and I put it in the grid, right? So I'm just taking this first term, putting it here, and the last term, -4, and putting it here. Well, then I just kind of guess and check. So I'm going to say x times x gives me my x squared. So now the next step of this is I got to think of two numbers that when I multiply them, they equal -4, but when I add them up, they equal +3. Well, I think it's the only factors of 4 are 1 and 4 and 2 and 2. So I think it's 4 and 1, right? So I'm going to say 4 here and a 1 here. Now, because -4 is negative, one of these has to be negative. I'm going to make the 1 negative because when I multiply -1 times x, I get a -1x. And when I multiply +4 by x, I get a +4x. Now, when I add up those middle terms, remember our goal is when I add up these middle terms, they should equal a +3x. All right, so 4x plus 4x minus 1x is 3x. So what does that mean? Well, that means that x plus 4 times x minus 1 are the factors of the quadratic x squared plus 3x minus 4. So x plus 4 times x minus 1, those are the factors. That's the prime factorization. So now remember, to solve this, I'm just going to take each one of these and I'm going to say x plus 4 equals 0, and I'm going to say x minus 1 equals 0, right? How do I know that? Because you got to think, what equals 0? 0 times 0 equals 0, right? So that means that this has to equal 0 and this has to equal 0 to equal 0. So then I solve. This becomes x equals -4, and this becomes x equals +1. And that's it, really, truthfully. Now, yeah. Let me just highlight the answers here. Sometimes kids will be like, well, what's the answer? Let me zoom out a little bit so you guys can see it. Okay. So just prior to us recording this, we talked about a pig farm and how many pigs you need to start off with and all this stuff. This could be a scenario where you have multiple. What if you had a farm and you wanted pigs and cattle and you're growing a crop? So you could have all of these functions that represent the population growth, or with regards to the log, it'd be the inverse of the population growth. And you could use these properties of logs and exponentials to kind of whittle it down and figure out how much time it'll take to get things, or how many things you need to start off with. Yeah. Now, what's nice about doing the math is that you have an exact answer, which is a better prediction, because a lot of times when people do this, they'll say, well, I think it'll take 4 years, or I think it'll take 2 years, or whatever they think it is. Unfortunately, that's not the best way to approach it. Although a lot of people that have been doing it a long time kind of know, but basically that's just the data, right? Businesses, there's a lot of people, and that's why people kind of struggle sometimes, is they don't crank through the math. And if you hire a consultant, they have some guy that sits in a cubicle. They'll just crank through the math and say, this is how many you need. This is what you need to do. But you got to pay that guy. So one particular profession is called an actuary. And an actuary is a guy that has a degree, or girl, in mathematics usually. And they know how to crank through and just do the math. And so they usually work in business somewhere, and they calculate all these things for people. So no matter what your business, but a lot of times because it costs a lot of money. In fact, it's one of the highest paying professions. Um, yeah. So insurance companies are the greatest ones. And I'm just kind of babbling because I'm waiting for you guys to finish writing all this down. But